at the last minute, so I apologize for the errors and the shortness of it. Well, maybe not, because so many of our presentations that are 1 hour presentations last two. This one will be short and sweet, I hope. But anyhow, so whoops. What I want to speak about is a handful of topics. What are our goals? It's not DSES goals. This is just radio astronomy. But what are some of the goals that I thought of? What is what kind of projects are going on? I wanted to make sure I gave a full introduction to a lot of things that are going on, and where radio astronomy fits in. What kind of tools are we using for radio astronomy? Uh, our hardware and software tools, our post-processing, and training. We've started a training process. So that's, I'm sure most of you have either been or at least seen. That's our site, looking from the antenna to the control center. And so anyway, with radio astronomy, we've been looking at trying to revive and expand participation in radio astronomy. And the problem is that radio astronomy is a complicated subject. It's probably one of the most complicated of all the various projects and things we have going on down there. And we want to expand the cadre of people who know how to do this stuff and who enjoy doing it, and try to make life easier to get involved. So one of the ways that we're going to make it easier, and we've already started this, is with training. We've had one training session so far, on Zoom, and we recorded it, and that training session is on the website. And that training session was planning. That's the first of the training sessions that I had in mind. Basically, we have, when we go to record information about pulsars or magnetars or hydrogen background radiation or whatever it may be, first thing you do is plan. Because if you get to the site without a plan, you'll never finish doing anything. Second part is practice. Now we can actually do data collection here. I can do it in my lab at least, and that is open to anyone who wants to come over here in Colorado Springs. And we're going to have a practice session, I hope, on Zoom soon. Then that's, here's my first mistake. It's data collection, not date collection, at Haswell. We're a couple, 2 or 3 of us are going to run down to Haswell who are not experts, who have not done this on our own before, and we're going to try to collect data on pulsars and see if we can do it without the expertise of those who already know how to do it, like Dan. And then, of course, post-processing is really the hardest part of all of it, because many times you will come home with a file full of noise, and you may or may not have any idea whether you achieved your goal, whether it was, in most cases, it's trying to receive a new pulsar, or maybe if we're just practicing, receive an old pulsar that we know is easy. But whatever, you might come home with a file full of noise, and post-processing, uh, even by experts, can take hours to weeks of effort. So that's upcoming. One of
That
the,
sounds, Rick, that sounds like Photoshop, 1/500th of a second to take the picture and hours to process it.
oh, absolutely. Yes, yes, for sure. Um, one of my goals is to look at all the tools that we use to uh, to plan, to collect data, and to post-process data, and try to simplify those tools so that we become more efficient, more effective in each phase of this activity. And I'll show you a little bit of what that means here in a moment. Uh, but we've already had some tremendous progress from the System 1 team on the antenna steering. That software has been upgraded significantly due to a totally separate project, the Artemis project, and the actual steering of the antenna is getting to be more and more automated. And when we get in trouble, uh, we now have the capability for the designers of that software to log in from home uh, to look at what's going on with their software without having to drive there every single time for something. And that's sort of part of the process of simplifying the tools, making them more effective, taking advantage of our new capabilities, like we now have fiber optic internet at Haswell, which is really wonderful. Side issue, by the way, thanks to a lot of effort and some donated labor. I now have fiber optic internet here at my house in rural Colorado. The guys down in the city, not so much. But some of them have it, some don't. But I'm out here in the middle of nowhere, and I finally have gigabit Ethernet. That would be very helpful. Um, So, and that leads to my next point is one of the problems that we always have is Haswell's a long ways from anybody. Those of us in Colorado Springs are probably about as close as it gets, and it's still 100 miles one way. It's a long drive, makes for a long day, so we don't go down there as often as we would like. Well, remote operation of radio astronomy is not only possible, but highly desirable, with the proviso that someone still has to be on site. Because if anything goes wrong while steering the dish, we need somebody on site for safety reasons to protect the dish from damage that remote control could cause. So it's not totally remote. However, you don't need a radio astronomer on site to do radio astronomy. You just need somebody who's qualified to steer the antenna and who knows what to do if something goes wrong. The rest of it can still be done remotely. So that means we should be able to expand our cadre not only to people who don't want to go down there all the time, but to people who are very, very far away. That is anywhere in the world. who have adequate internet connectivity ought to be able to do radio astronomy. And to assist in that is not only remote operation, but I'm proposing that in the future, we post not only the results of our post-processing, where we, in past science meetings, you've seen we pat ourselves on the back, Dan does a presentation, puts out all the fancy charts and circles and arrows, and says, we succeeded, and now we're going to go on to the next goal. If we post our raw data, as well as maybe some results, we can let anyone who wants to do post-processing of data, which is where 90% of the real radio astronomy takes place anyway, and compare results with each other. That I think would be really exciting, because there are various tools, and even with the premier tool that we use today, that's there are many ways of using that tool that we are not currently using. I only just discovered some of those ways today, so they're not even in the presentation yet. So, part one. Are there things going on at Haswell, at DSES, that you might be interested in? I'm sort of hoping radio astronomy might be one of those, but all of these pieces here are off the website. Go to the website, look under projects, and see if there's a project there that many of those projects are in need of being finished. And some of them require a very small amount of engineering or software or maybe physical labor to finish them and get them back online. Others of those are going full steam ahead, but there's always room for new volunteers. We have pages. One of the links on the website is called projects. It's the links are up on the top of the main page. The links we're going to talk about, or the things we're going to talk about for the rest of this, are under science, not projects. Under science, you'll see a web page that starts off with pulsar and magnetar astronomy, and this is just the beginning of the page. There's a lot to learn there. And the second entry under science is training classes. And the first class is available on YouTube. You can click on it right there on our webpage and catch up. And if you watch that and have any questions, you can email me. My email's at the last slide here. So why do we do radio astronomy? There are clubs all over Colorado that do optical astronomy, visible light, but there's a lot you cannot see with visible light. First of all, you can't picture, now light and radio waves are the same thing. They're just different frequencies, part of the same spectrum. And that spectrum, depending upon what version of quantum mechanics you study, is either a wave or a particle. I believe it's particles, photons, but that's okay. You can take it, this chart is in wavelengths, not photons. But that's okay. Well, you'll see here that the visible spectrum of light is broken up by wavelength into different colors, but it's a very small part of the spectrum of stuff. Most of the spectrum is completely blocked, 100% opacity, that is blocked by the atmosphere, the ionosphere, the troposphere, and so forth, and you can't get through. So we have satellites out there doing astronomy at wavelengths shorter than light and longer than light. But if you go even longer wavelengths, you wind up with a huge chunk of the spectrum, which is transparent, more or less transparent, to what we call radio waves. And that's a great place to look. And if you take at the picture here of radio light versus visible light, is what you see through the telescope of that's a portion of the Milky Way. The radio light is various frequencies of radio waves that are artificially colored, so it makes a nice picture. And you'll see they're looking at the same place. And you'll see that often on radio waves, we can see things you cannot see in the visible light spectrum. So that means they're very complementary to each other if you're looking for certain things. Now, one of the things we often look at, this is not pulsars, but one of the things that we will look at sometimes when no one is at the site and the antenna is pointed more or less up in its safety or bathtub position, we'll scan the sky in what's called a drift scan radio astronomy, looking for hydrogen line emissions. And hydrogen makes up most of the universe. So there's a lot of it out there. And hydrogen occasionally gets energized from whatever mechanism. There may be particles or photons of energy that hit the hydrogen and put it in this thing, this high energy state called the triplet state, and then eventually that drops back to the singlet state, the base state. And when that happens, it emits a photon at 21 centimeters. That's 1420 megahertz. So we'll tune into 1420 megahertz, plus or minus, and we'll listen there. And we'll do that for days and days and just scan the sky looking for what's out there. By the way, it's just sort of an interesting fact that this triplet state is called a forbidden transition state. Meaning it's almost impossible to get a hydrogen atom to do that. A typical atom in the galaxy will only do that every 11 million years for one atom. So it's really, there's not a lot of energy in this because it's very seldom that this kind of transition happens. But even though it only happens once in 11 million years for any one atom, there are 10 to the 60th atoms in the galaxy. So if you multiply that out, there's still a pretty fair amount of radio noise at 1420 to look at. And when you do, you can paint these beautiful pictures. And I didn't have time to grab one for you, but they're really pretty pictures of colorized pictures of the Milky Way, for instance. It shows up beautifully this way. So this is something we can do with nobody down there steering the antenna. And I've been collecting data. I stopped for the last few months on this because were rearranging hardware and we had a different project going on. But this project will be turned back on, and the data files for this are online and easy to access. Just call me. Oops. Ah, my mistake. Here's a picture. It's not one of ours. I didn't have time to grab one of ours. This is just off the internet, but it's a famous picture mapping the Milky Way uh, by looking at the hydrogen atom emissions. So this is the kind of thing we can build uh, at Haswell, and most of the amateur astronomers that I'm aware of in the world are, oops, I'm just wondering what that was. Most of the amateur astronomers I'm aware of are doing this kind of thing with very small dishes. And they're getting results that are good, but they're not as fine-grained and detailed as we could do at Haswell. So I'm looking forward to getting this experiment back up and running, because this is something we can do 24/7 whenever the dish is not in use for some other purpose. Now, pulsars, these are really nice little fellows. We think of pulsars as pulsating radio signals. And we will receive radio signals at various frequencies that pulse anywhere from milliseconds to seconds. So, 1,000-to-1 ratio of pulsing. So you can, if you are looking at pulsars that you know what you're looking for because somebody else has already found it and cataloged it, then the catalog will say, the pulses are once every 100 milliseconds. And you'll say, I recorded the data at the right azimuth and elevation, the right point in the sky, and it has the right pulse rate. So it must be the one I was looking for. And you can see here why they pulse, because these pulsars are really neutron stars. And neutron stars are really nasty little fellows. They mean what they say. They have no electrons, no protons, just neutrons. And what they wind up with is this mammoth magnetic field, and they spin and they throw off energy off the poles, not necessarily where they're spinning. So those emissions from the pulsar might just happen to hit Earth. If it's spinning just right and Earth's in just the right place, we will see the energy emission every so often based on how fast it spins. Well, every so often tells us a lot. It tells us how fast that star is spinning. And also, the energy is not concentrated at a single frequency like the previous experiment. It's over a very wide range of frequencies, and some pulsars have more energy at, say, 400 megahertz, and some have more energy at 1600 megahertz or some other place. So you learn a lot about the pulsar by where it's received the strongest. And then you learn more about the pulsar because the pulses are not precise. They're spread. And sometimes they actually have dual pulses. And you can learn a lot by looking at the pulses and inferring characteristics of the pulsar from what you see in these pulses. I didn't put up on the charts, but yeah, someday I will. There's a wonderful book that explains all of this in detail and with text that we can understand. Uh, and it's highly recommended. So, in any case, we I didn't put anything in on planning. As I say, I didn't have enough time to put all the slides I wanted here, but you can go to the planning, to the, I'm sorry, the training website and play the YouTube video and understand that that one's all about planning. Planning says, I need to know what pulsar I'm going to look at. So I've got this list of pulsars that we've already seen. And maybe my goal is to see a new one that we've never seen before at Haswell. Or maybe my goal is just training, so I'm going to pick one I know is pretty easy to look at, whatever my planning is. And you also need to know what time the pulsar is above the horizon. That's really important, particularly if you're lazy and want to go down there and look in the daytime. So you can drive down, you get there about 11 a.m. and you're going to leave around 5. So you look at the pulsar charts and say, I wonder what's up next Saturday between 11 and noon local time in Haswell. And that simplifies your choice of pulsars if that's your schedule. See, so yeah, I encourage you to look at that YouTube video, find out all about planning. That's basically comes down to that simple. When am I going to be there? When am I willing? What is my schedule flexibility? Do I want to do daytime, nighttime, whatever? There's always a pulsar for you. And then when you get there, we need to operate the system. And the first thing we need to do is operate the dish. And there's a whole procedure for doing that, and you need to be trained on how to do it. But after you run out to the pedestal and throw the right switches and come back inside and make sure the plugs are in the right place, there's some software that looks sort of like this. And there are there are menus, and buried in those menus are choices of pulsars. Just about any of the pulsars you could possibly want are on charts already. So all you have to do is pick one and it'll steer the antenna. Of course, you can steer it manually. You can pick your own azimuth elevation or right angle, right ascension and declination, pick it and run it yourself. But what you really want to do is go in and to your astro guide and find your pulsar and let it steer the antenna automatically. Makes your job really easy. Then you want to look for RFI. And if you look at Dan put up recently a PDF file describing the whole process of radio astronomy from one end to the other. It's a nice read. And in there, he shows the old spectrum analyzer. And he didn't say much about it, except we're going to look for RFI. So I've spent the last few weeks designing a replacement for the spectrum analyzer. And this is just a screenshot of it. I have it running here. And my goal was to try to make life easier for radio astronomers. Well, what does that mean? That means you might have any number of your favorite software-defined radio that you're going to use as the engine to look at the spectrum. And gee, wouldn't it be nice if the spectrum analyzer saw, oh, you plugged in an AirSpy, or you plugged in a USRP B210, or you plug in whatever you want. And it automatically detects the SDR. The spectrum analyzer that was shown previously does not do that. You have to go in and manually readjust all the settings in the new radio, and it is a real pain. It can take a lot of time. And so you previously we would generally show up with a configuration already on a computer with all the hardware, and we bring it all with us and plop it down and use that, whatever that is. In this case, this is just an example of how I want to make life easier. We've got software, it can be on your laptop, can be on a DSES computer at the site, which is what I'm hoping to do, is have a permanent radio astronomy computer on site at all times. And you just plug in whatever you want, and it'll run. And all the menus will automatically adjust to the capability of that receiver, because it has a whole list of receivers built in. And then I asked Dan, I said, well, what bands do you want to look for RFI in? That is, what bands do we want to consider for radio astronomy? And I added to those some other frequencies that might be interesting for projects like EVE. And so we have over here in the upper right corner now, we have preset frequencies. So we don't have to type in frequencies and move around and drag displays. We can just hit the presets, and then we can drag them a little bit with the coarse and fine tuning, or we can just go to manual and plug in any frequency we want. And on the left-hand side, the spectrum controls, they're not all shown here because there's a drag bar here, because they didn't all fit. But in any case, you can change from dark background to light background. You can make any of the waterfall display and the spectrum display any color you want. You can adjust the line thickness. You can adjust the FFT parameters. You can adjust anything you want. And you can adjust the relative gain. On the left side, you can adjust the frequency width, the bandwidth of the display any way you want. You can do both at the same time with your mouse wheel by putting it in the middle. You can get in so much trouble that I added a reset axes button here, because it's real easy to get the whole display messed up. So we have resets. And there's many, many other things you can adjust and observe to see if things are going okay. But the whole idea, and you can even close these menus so that you're just looking at the spectrum, so you can capture that and put it in your final report if you like. But it is so easy to use now as compared to the raw GNU radio one, there's no comparison really. And it is available to run on any Windows 64-bit Windows computer, Windows 10 and 11 basically. And it'll run on any Mac OS, whether it's an M series Apple chip based unit, or whether it's the older but still very capable Intel chip Macs. So if you bring like your MacBook Pro, this will run on any MacBook Pro. It'll run on any, I should bite my tongue for saying this, but any reasonable version of Linux. And I'm not sure about the Raspberry Pi. It might even run there. But anyway, so the distribution will be easy. Well, it's not trivial to install, but it's not that hard. And I have a PDF describing in detail how to install this and make it run on your computer. And if you don't have a fancy multi-thousand-dollar USRP SDR like we have at Haswell, you can take your $100 SDR and it'll run just fine with this. And if you don't have any SDR at all, but you want to learn how to use this tool, and if it comes up and sees that you don't have anything plugged in, it will actually go into a playback mode and play back a file so that you can learn how to use all the controls, and then it has a simulated SDR. So it'll work for anybody. And I'm looking to do this kind of simplification on all the tools as time permits, so that it gets easier and easier to operate things at Haswell. Now, we also need, you're going to see why in a moment, we have recently installed a precision time and frequency rack that has a rubidium that is calibrated to GPS and has its own data collection mechanism for managing the calibration 24/7, has its own UPS, has its own NTP server for providing timestamps to all the computers within the LAN at Haswell, and it provides a 10 megahertz reference at approximately 1 part in 10 to the minus 12 accuracy for 10 megahertz to feed the SDRs and computers and other things. In some cases, like the 8 gigahertz system, we feed the down converter with it so that everything is synchronized to this master reference 10 megahertz. Now here we can see an example of what happens when Dan post-processes a pulsar file. This happens to have been a fairly recent and very interesting and successful post-processing session. And I say that because the raw data, when thrown at these tools quickly to see what we had, looked like it was completely useless data until Dan took it home and applied what are called dispersion and folding algorithms, because the actual data was not synchronized well, and it was drifting badly, and the folding didn't work because the drift was so bad. Well, the dispersion took care of that. This took him a fair amount of time. And this tool called Presto will provide all of these different graphs all at once. And what I didn't know until today is that there are other, this is the standard presentation Dan and I think Richard before him have been using for years, but there are other presentations that Presto is capable of doing, and going through its capabilities and providing some other forms of pulsar evaluation may turn out also to be very useful, especially for training. So I'm not going to go through the details of this because I can't. I don't know enough to do that. Um, but I do know what is going on here, and one of my goals is to learn a great deal more. I know a lot about engineering, but the science here is of great interest to me because it's something I don't know nearly enough about. So between this textbook I mentioned and Dan's help with knowing he's learned a great deal about the science of pulsars and how to use this particular well-known post-processing tool called Presto. I'm hoping to learn a great deal more than I know at the moment. So, how to get involved? Well, I could say from this picture, just call Bill. he he got involved, and although and he spent most of a few years building this building. Well, you don't have to build a building, but if you'd like to get involved, there we have a small core group of people who have said, we want to know what Dan knows. We want to know how to plan, collect, and post-process pulsar data and go beyond that, magnetar data, and maybe even drift scan hydrogen maps of the universe, and maybe other things that are interesting to radio astronomers. And we have one of the largest amateur radio telescopes in the world. There are a few that are a little bit bigger than ours, but 99% of them are a whole lot smaller, and they do good radio astronomy as amateurs also. So we have an asset here that is pretty unique and is available and accessible. And the first thing that I recommend for anyone who's interested, even casually, is join. Now, why? Well, because every time someone joins, it supports our ongoing projects and radio astronomy. And that is very helpful. And we try our best to have at the moment, two monthly virtual meetings, one called engineering, one called science. Sometimes I think we get the two mixed up, so I recommend attending both. Uh, and so unfortunately, the engineering meeting got canceled this month, but the science meeting is here. We knew that it would be a challenge to get people here because it's a holiday and everybody's out doing things, but nonetheless, we like to try to keep the meetings going. And if you're at all interested in joining up in any way with the radio astronomy core group, just send me an email and we can talk about that. That's really straightforward. So uh, if you're out at Haswell at night, that's what it can look like to the naked eye at night. Just your basic cell phone camera can make that picture. Absolutely gorgeous. So that's it. Uh, I don't even know what time it is. I hope I kept a short meeting for a change, and I'm open to any questions or comments.
Yeah, hi, this is Aaron. Where do you store all this data that you're going to process?
Well, that's a good question. Uh, there, we have a number of computers. I should have provided, I did not. That's just a piece, one little corner of our console. I should have put in a picture of the whole console. There are a number of computers there all the time. For instance, the drift scan data for the 24/7 drift scan experiment is recorded on a 1 TB M.2 solid state hat on top of a Raspberry Pi 5. Now that doesn't sound like much, but it's enough to store years worth of data. And then I upload that data occasionally from my home here, where I have much larger capabilities. I have a network attached storage device with 57 terabytes of storage. We would like to do something like that. I'd like to have a network attached storage device at Haswell, but to get something that big is expensive and it's not in our budget at the moment. So basically, we store it on computers in 1 or 2 TB chunks and upload it to places like here or to Dropbox locations. And I have a couple of virtual machines that I can use to store data also. But in the long run, it'd be best if we had it either in the cloud or at Haswell or both, bigger storage capacity. But that costs thousands of dollars, and we need donations or we write proposals and try to get money to do those kinds of things. Problem is, if I want a network attached storage device, Bill will remind me of the 25 other things that he wants. And so it turns out there's a lot of things we need at Haswell, but we have just enough to get by right now with data storage capability. Anything else?
That's pretty good, Rick. You kept it well under the time budget.
Yeah, that was the idea.
Very interesting. So how many we're going to have what, 4 training sessions on pulsars?
Well, that
We've
was
already had one, right?
Yes, that was my intention. So the second one has been held up by a couple of things. One is it's taken me a great deal longer to write the Python code that wraps all the libraries to make that spectrum analyzer. And I really wanted to have that as part of the data collection in the lab and data collection at Haswell for the next 2 training sessions. The other thing is, let's see if I kill this. It's another slide I wanted to put in. Unscrew the collapse of the power. I have this remarkable little device here that some of you have seen before. This is a pulsar simulator. It provides signals that simulate a pulsar so that you can feed the output of this into your SDR and actually collect data as though it was a real pulsar. And that's part of the the data collection demonstration in the lab. And by the way, that hardware was designed and built by Ray. And so I'm making sure that that's working properly. And I have one last piece of software I have to go through to make sure it meets my standards for what we're trying to do here. And that's the actual data collection software. Turns out my spectrum analyzer can also record IQ data in SIGMF format. And our actual data collection software that Dan's been using does not do that. It records in a much more compressed format that is easier to carry around. So I've got to be sure I have all that up and running properly for the next training session. But we will have a training session here, and then I think three of us who don't know how to do this are gonna run down to Haswell and try to collect live data. And if we can demonstrate to ourselves that we can do that, then we'll have a training session from Haswell based on that. And then finally, and I think the most complicated one will be a training session on post-processing. What do you do with all this data once you've got it?
So Rick, it sounds like you're discovering that in terms of software, that the first 90% of the project takes the first 90% of the time, and the last 10% of the project takes the other 90% of the time.
Yeah, for sure. The I am discovering that by the more I do, the more I learn. And by trying to prepare things to teach you about radio astronomy, of which I know very little. So even to put those few graphs together, I know a whole bunch that should have been in there that aren't, because either I ran out of time or I don't know enough to build them. I know what they should be. So I'm learning more by doing things here in the lab at Haswell and with presentations than I would ever learn if I just sat back and waited for somebody else to try to teach me.
Mm-hmm.
And that's what this little core group that I was talking about seems to want to do, is put their fingers on some of this stuff and actually try to make it work. And there's no better way to learn. Just grab a piece and say, aha.
Okay. Are there any more questions?
Yes,
Okay.
Roger. Excuse me. Yes, I have
Sure.
one. Rick, you mentioned a book, but you didn't tell us what the title is. Could you please tell us what the title is of the book you were recommending?
If I tell you that, then you'll know as much as I know. And that's not good.
Well, you kindly assume that I could understand it. So, what is it?
Handbook of Pulsar Astronomy.
Thank you.
That looks sort of backwards to me. Pulsar Astronomy by Lorimer and Kramer.
Thank you.
And the good news is it's not too big a book. See? The bad news is you need a microscope. Yeah, they made it in small print. And us old guys. And yeah, unfortunately, there are equations.
Oh dear.
However, what I've discovered about this book is if you just read chapter 1, you will know almost everything you need to know. You'll know why we look at pulse widths and rep rates and frequencies, and you'll know an awful lot just after reading paragraph or chapter 1. But I think people like Dan, I bought this one because I looked at Dan's copy and it was totally, he needs to buy a new one. He's earmarked about every page and he's read the whole thing cover to cover about 10 times. I'll
Wow.
get there.
So
Thank you.
in the chat window, I pasted an Amazon link. That doesn't mean you have to buy it from Amazon. That just happens to be where I just looked it up. And so there's a link to that book.
Great,
in the
thank you.
chat.
Thanks.
Yeah. Now, of course,
Did you get
there
the link?
is an equivalent book.
Oh,
See, I asked the guys like Dan, I said, what is the one book that I can read? You know, and Dan just got another book, which is the one book for magnetars. Now, magnetars are crazy devices, and there's a whole book on just that. So, and I don't remember what that book is. I haven't bought it yet. I figured I'm having enough trouble getting through the pulsar book. Magnetars are also neutron stars, so they're just really crazy nuts. They're way over the top. And we did actually look for and detect a magnetar, and Dan was thrilled when that happened. Because that was something we had never done before. See, there's always something we've never done before. So I encourage you to pick something. It can be simple and still be something we've never done before.
Rick, thanks a lot. Appreciate this very much. Hi, it's Larry. Are the training sessions going to be on the science presentations, or they're outside of the normal DSES?
No. These we do them on Zoom and record them, and then we post them on YouTube, and then I put that picture link on the science page, on the training page, science/training on the website, and you'll see ones there already. So they'll be announced to everyone, and they'll be on Zoom, but only a handful of people can actually be there at that time on that day. So that's why we record them and publish them.
Makes sense. Thanks. Roger, thanks for hosting this. And hi, Ann, it's good to see you.
Hey, Rick,
Go ahead.
can you hear me? There's another book that I got called From the Great Courses. It's well, let me see where it goes. Radio Astronomy.
cool.
It's a DVD, and it comes with a textbook, and there's about 24 30-minute courses. Let me see if I can get rid of the backdrop here. Yeah. Anyway, it's From the Great Courses, the radio astronomy book, and there's 24 different 30-minute courses presentation. It comes with the book as well as with the DVD, or you can stream it online, and it's 40. Let me see, 40 or 50. It's $50 still available through the Great Courses website.
Okay, I will order one for myself for sure.
Yeah, I'd recommend that to everybody, Myron. That's the one I got, and I think a lot of the people here have picked that one up. But that's a great introduction to all radio astronomy, and you go through that one, and you got a basic understanding of all the different aspects of radio astronomy.
Could we get a link for that in Bill?
Yeah,
Do you still have Amazon up? If you could just post
You gonna
paste
do
the
that,
link.
Bill?
Let me see if I can find it. Let's see. It's actually not on Amazon. It's the Great Courses.
Thegreatcourses.com.
Yeah, got it. Okay.
I'm there, but I haven't found their
And
books.
it's
Oh, here it is. Shop. There must be under shop.
It's also in the chat. Ted posted it. Thank you, Ted.
Thanks, Ted. Yeah, here, I'll pull that one up and you can see the cover. Let me share the cover here.
One of our former members, who was optical astronomy, he bought this book and with courses with DVD, and I bought one. And when he left for the organization to go back to California, he said he would rather do optical astronomy. He was overwhelmed by radio astronomy. So anyway, of course, he had all the telescopes for optical astronomy anyway. So I do have an extra course here that I would loan out to somebody. There it is. Yeah. That's the second edition. Mine is the first edition.
This one's up on eBay, but you can also get it directly from the Great Courses. And if you don't have a Great Courses subscription, you ought to get one because there's all kinds of great stuff on there for all kinds of things. And
that one comes with DVD as well. The one you're looking at.
Yeah, it comes with a DVD. Well, I don't know if this one does off of eBay, but
The
original does.
You bet.
Yeah.
It says DVD set.
Yep.
And you can stream it too. If you don't want a DVD, they'll let you stream it, download it. So
yeah,
you have an option, either or.
I was gonna if we've had discussion on that, one of the things I wanted to say, if you're interested in what we're doing and you don't want to dig into all of this, there's all kinds of other projects, just basically handyman projects and mechanical and electrical projects that we undertake for the DSES site. And go ahead.
That Great Courses even has some courses on understanding those mathematical formulas too.
Yes. But what I was going to say was, if somebody wants to just, get familiar with the site, you learn a lot by osmosis just by being there. Because you learn how all the different systems work. So in the time I've spent with the group, I've touched every system at the site in some way and repaired many of them, installed many of them, and you learn a lot doing that. And so I have a projects list that goes on, and this is supposed to be posted on the website. When I looked just now, I couldn't find it. But these are all the building infrastructure things, the cistern, the heat pumps for the building sealant to keep the water out, the outhouse, the storage sheds, the electrical work, all the different things. The network, Roger came out, Richie, Larry, and Roger came out and worked on our network. They got that running. All these things that are crossed out are things that we've already done. But there's also a lot of them that aren't crossed out that if somebody wants to help, they can just pick up a project or a task here and go do it. Like if somebody's a tower climber, erect the east and west Rome 45 towers around the building. We want to put 4 sections on each one of those towers and install the antennas for the HF and the VHF, UHF radios. Security, the security cameras, working on the bunker and the flooding of the bunker, the generator shack, the communication trailer, the battery shed, all these different projects that we have. One of the interesting things that just got done, Roger picked up and did a design and a new build for quick feed antenna mounting on the dish hub. It's something that he came out, looked at, said, this is something I want to do. And he came up with this great dish or feed antenna mounting scheme that we can change the feed antenna out in a very short time. It used to take us a day to do this. And then Ray did some work and we shortened it to about 4 hours. Now we've got it down to we can put a new feed up there in about half an hour. So things that really help save some time, some site time. Most valuable thing we have is site time. And so anything we do that makes the site more efficient or repairs the site really helps with everything that we're doing in radio astronomy. But so these are all the tasks or the projects that we want to do. Look for that on the website. I'll have Bill or Rick post it up on the website, and just look through that list. And if you can help out with some of it, that'd be great. Just let us know.
Yeah, we still got one other 12-foot dish to relocate down there as well.
Oh yeah, we got another 12-foot radiometer. We have a 30-foot dish that's on site that we need to reinstall, and so that's going to be a big project. We're going to need a lot of people to work on that. We sent 9 people down near Durango to pick up the dish, to take it apart, get it down with a crane, load it on trailers, and bring it back to Haswell. And it'll probably take that many to put it back up. And so there's a lot of projects that go along, or tasks that go along with putting up this 30-foot dish. And when we have a 30-foot dish and a 60-foot dish, we can do a lot more radio astronomy and ham radio work, like EME work and that sort of thing, once we have a 30-foot dish up. So there's lots of things to do, lots of ways to get involved, and we can sure use the help on site. Any questions on that?
I have a question, not necessarily on that subject, but with this is Adrian.
Yeah, Adrian.
With the participation that the SES had with Artemis 2, I
Yeah.
noticed the other day that NASA had put out an initial notice of, I guess, interest for Artemis 3. So I was just curious if you were planning on maybe also participating on that.
Oh yeah, yeah. I think we'll definitely participate in Artemis 3. I don't know, the schedule for Artemis 3 has changed several times. I'm not too sure when it's going to be. Haven't followed it that closely. If you know, that would be good to know. But yes, definitely, we intend to track it. We had a lot of problems with Artemis 2 tracking, and Roger came up with a fantastic workaround that our tracking system actually failed on the second night that we were tracking. First night, I got good data. Second night, I go out, I turn the system on, and the dish starts tracking the wrong way. This is why we have to have people on site to move the dish. This isn't something we'll ever do remotely. We may get data remotely, but to move the dish, we have to have people on site. And here was a prime example where a little module failed and the dish started tracking in the wrong direction. And if we hadn't caught it, it would have wrapped all the way around and possibly damaged the system. So we had problems with that. We lost the first, the second, third, and fourth night of data. And then Roger came up with an idea of playing manual Pong with the manual controls, flipping switches and controlling knobs, and was able to track 2 additional nights, and we got a lot of data off of that. So a lot of interesting workarounds. So it's kind of like auto racing. You know, if something goes wrong, you find a way to fix it. But yeah, we'll probably track Artemis 3 as well. But hopefully everything will work and we'll get it all the way out and all the way back.
Yeah, that's excellent. Well, I'm sure you're aware that NASA lost one of their big DSN dishes with a similar problem. It just it went past the stop limits on the on one of the tracking directions and ruined all kinds of the equipment. So
Yep.
you're not the only ones that experience that kind of situation.
Yeah, it happens.
When did that happen? I hadn't heard about that.
Well, it was a few months ago. I think one of their largest dishes is out of commission. I'm not even sure if they'll be able to even repair it, but one of the DSN network dishes. I'm sure you can go online and find the information on it. But
Yeah, I'll Google that.
it did a lot of damage. It had a tracking error and just went past the limits and just tore out I believe some cooling systems. I think it flooded the equipment room and the antenna. All sorts of damage, which is kind of depressing. But yeah, I'm sure you can find the information online. That was kind of not too great to hear about that.
Yeah,
Yeah,
a lot of things can go wrong. Go ahead, Roger. I'm sorry.
No, I was just going to say I'll go ahead and Google that. Go ahead, Bill.
Okay, I was going to share one other thing here. This last weekend, here's an example of a maintenance item. This last weekend we went out. One of the things we did was we took down the tower. We've got about a 60-foot radio tower out there with a 3-band beam on it, tri-bander, and a 6-meter beam. And the thing got twisted out of position. And so we took that down, realigned the antennas, reconnected the coax that was broke, and put it all back up. So that was one of the projects this last Saturday. And then the other project, this picture that I'm showing you is the azimuth drivetrain. It's the on the sprocket that's closest to us on this chain. That's the motor drive. That comes off the motor. And the other side goes into the gearbox, the thing with all the grease on it. Okay. And this sprocket on the gear train apparently had never been replaced. And so this is the one on the motor, and it looks really good, got good teeth on it. Don Latham will get a kick out of this, but we've got a really good interface with the chain and the sprocket. And then this is the one on the other side. And if you noticed, these little teeth on this thing, and I'll give you a better picture here in a minute, but the little teeth look real pointed. And so they aren't real good sprocket teeth. And you can see there they look really sharp and pointed and worn sideways. So they're, instead of being round in the bottom, they're kind of oval in the bottom.
That's
And
what
so
we used to call in my youth, cruising for a bruising.
exactly. And so what we did, this is the new sprocket that I bought.
Oh,
This is about
cool.
$100 sprocket to replace this with, and it came in two parts. They have a modular
Yeah.
system. But I'll go through these real quick, and you'll see here, you can see how the teeth should look. This is a brand new sprocket. The teeth are nice and square and well defined. And then this is the old
Oh
sprocket.
my God.
Okay.
Just in time, Bill.
So we replaced this.
Jesus, just in time.
And that's what I figured. And you've noticed it's marked with 40, which means the Series 40 chain. But I wanted you to see this because we have many, this dish is is probably 60 years old. And I don't think that this sprocket was ever replaced in the history of the dish.
Nope.
And so when they put the new motor on, it had a new sprocket and a new chain, but they never changed this one out. And so this was destined to fail. And so those are some of the maintenance items. And in doing that, we learned a lot about how the dish operates and how everything's put together. So I thought I'd share that with you.
Well, that ought to cut down on the backlash a lot, Bill.
Yeah, it's a lot quieter.
Yeah, really.
Yeah. And this thing was honed by the chain, and it is so sharp that we cut ourselves on these teeth. These teeth are like razors. And it shouldn't be like that. So anyway, so I'll bore you with that. But
You want to say
that's all
who
I
helped
got.
you do that?
What's that,
Bill?
Myron?
You want to say who helped you do that this weekend?
Yeah, Tony, a gentleman that's new. He's a fairly new member. What's Tony's last name? I don't know if he's on. I'm sorry. It's Hagen, I think.
Yeah, correct. He's
Yeah,
from,
Tony
he's
Hagen.
a local
He's
guy.
local, and he's a rancher down there, and he's also a radio guy. He's done cell towers, radio towers. He owns several repeaters down in the southeast corner of Colorado. So he's not new to radio, but he basically crawled up in there and replaced the sprocket and saved me a lot of sore muscles and cramping. I'm quite a bit older than him, and climbing up into the system like that was not a place I wanted to be. But we got it fixed, and so that'll make a difference. So now we'll probably also replace the chain, because this obviously probably was wearing the chain improperly, and we'll use that chain's only 2 years old, but we've used it quite a bit, and it may have worn the chain some. So we'll get a new chain as well.
Bill?
Yeah.
Where did you buy the sprocket from? Dishes R Us?
Yeah, this was from Space Leap Sprockets. If you Okay, so no, it was from Whistler Industrial, which is a company here in Colorado Springs that carries a lot of industrial gear. I tried Granger, and they couldn't.
No pun
get one.
intended. Industrial gear.
Yeah. And they had one. There's other online purveyors, but what I decided to do is, if I could get one from the Colorado Springs area, if it turned out to be the wrong thing, or if we didn't measure correctly, I could bring it back.
Yeah.
And that would have been a much easier process than going through a mail order system. So, and I'd like to support the local economy anyway. So that's what we did.
Yeah, for you Colorado Springs people, if you haven't ever gone to Whistler Bering, which is it's just off of Nevada, near the old dog track on the other side of Nevada from the old dog track. It's an interesting place.
Yeah, they got a whole bunch of stuff. So anyway, that's all I got on that.
All right. Since we're experimenting with a new format here, does anyone have any general science questions that we could quickly answer? I don't want to go too much longer here for the meeting, but if anyone's got anything in general that they need to get answers to, go ahead. Hearing nothing.
Crickets.
What? Oh, I thought someone said something. Okay, yeah, I heard the crickets. Okay, so I do want to remind people that not this weekend, but the following weekend, there's going to be some 8 gigahertz experimentation going on down at Haswell from what is it, Thursday the 4th through Saturday the 2nd. So 4th of July through the 6th of July. Sorry, June, and I'm going to actually be going down there on the 4th of June, probably staying at the Cobblestone overnight and coming back on the 5th. If anyone wants to ride along but get your own hotel room, you're welcome to come along. And then our next meeting is the science meeting, which will be held June 8th at the same time at 6:30. And if I did my setup correctly, the link you used for this Zoom meeting should work for that meeting as well.
Well,
Yeah,
Roger, if you want to swing by Chicago, I'll happily ride with you. But
Okay.
actually, I am planning to attend.
Okay.
Yeah.
Well, if you want to fly into Colorado Springs, you're all set.
You know what? I might actually look at that. I'm getting a little tired of that drive.
Yeah, that's a long drive.
You also actually have an option probably of flying into Denver, because I know that Paul will be picking up Alex up in Denver. So Alex is coming in on the 4th.
Yeah.
But he's staying through to the 6th, where I'm just going to be down there just the 4th and 5th. So
Well,
yeah,
I wouldn't.
go
Sorry,
ahead.
Roger.
No,
I was
go
going to
ahead.
say, Larry, it's good to see you again. He was my partner in crime down at Haswell for Artemis. And I highly recommend that you come and do it, Larry. We miss your good company.
Yeah. Thanks. And the plan is I still need to get a couple of clearances, if you know what I mean. But I think I'll.
Oh, yeah.
He's also the best cook too.
Folks, about 20 minutes ago, we were talking about courses, and I gave the link that first came up. That's all about astronomy. I put a second link in there that's actually about the radio astronomy by
Oh, okay.
Felix. So have a look at the second link. I think that's the one we were talking about.
Yeah, correct.
All right. Is there anything else that folks would like to talk about or anything like that? Going once? Going twice? Okay. Well, thank you all very much for attending, and a much better turnout than I expected on this Memorial Day evening. But again, our next the engineering meeting will be held on June 8th, and I hope you can all attend there as well. Thank you very much for coming tonight. You all
Very
take
good.
care.
You
Thanks
too.
very much, Roger.
Thanks, guys. Good fun.
Thanks, Roger.
Thank you.
73s, everybody.
7-3.
73.